Good morning, everybody. Mike here from Southern California. Today I wanted to do a lesson that was on 3D printing, coding, and something that would integrate a STEAM experience either in a math classroom or any classroom really. And it's actually very, very flexible. We found you can use it in upper elementary all the way up through high school. So let's dive into it. We're going to be using a program called BeetleBlocks, but I thought I would say if you go to our website, csmmath.org, and you click on lessons and go to secondary, you'll find all of our lessons. In here you'll find exactly what we're going to do. This lesson is actually called Solids of Extrusion, and there's one similar to it called Solids of Revolution. Both are strong, and if you've never used Scratch before, I would really strongly recommend going back and doing playful polygons to start to better understand the things that will help you for the BeetleBlocks lessons. So again, we're going to use beetleblocks.com, so you can go ahead and open that browser, and yours will say like join up here in the corner. So I would go ahead and create an account and click join, and then once you've joined you can go ahead and click run BeetleBlocks. Alright, so you could pause now and get to this place because I'm going to pick up and try to show you how to make our first 3D solid. Okay, so we're going to go and pull out the flag in the control menu to start. We're going to pull out the space bar and put a reset underneath it. So what's nice is when we start doing things, I can now space bar and it will reset and clear up everything, which is a pretty nice function. So what I thought I might do is just pull out some code. Let's say I pull out a move block. I pull out a rotate Z by 90 block. And then I pull out we'll just pull out a control. So scroll down and in the control menu, we want a repeat block, and I can just wrap this stuff in a repeat block. I'm also going to pull out a wait block for a reason I'll show here in a second. So let's say I don't want to repeat 10, I want to repeat 4, and I don't want to move 1, I want to move 4. So the starting question I have is, what does just this code block do? Okay, if you don't know, again, if you went back and did playful polygons, be a great lesson just to get you thinking about it. But in order to see it closer, I'm going to put in the loop this wait block. This is actually a pretty good strategy. It works well for students too. But notice our beetle here in our screen. If I scroll in on him, and I scroll kind of at an angle again, if I run this code block, notice how he's moving 4 spots, turning 90, so moving 4 spots, then turning, rotating 90 degrees in the Z direction, and then waiting 1 second. So 1, 2, 3, 4. So 4 moves of 4 and then turn 90. So if you said it's making a square, that was correct. Now in Scratch you could make a draw. It does things two-dimensional, but in BeetleBlocks we can actually extrude. So if you go to shapes and you pull down to let's see, would be start extruding. Found it's cleaner to do lines for this particular one, so start extruding lines, and then let's snap that code in and click our green flag. There we go. So now we are building a square, and it's just like a 3D printer would. It's extruding out filament. And then if I hit spacebar, all of that will get reset. I'm going to pull out this wait block and just leave this code here. And let's think about if we're trying to build a prism like is shown here, essentially is what we're going to do. That's what the lesson is about. One way you can think about doing that is actually making smaller and smaller squares over and over until it fills in the bottom. So let's think about that. One thing we could do is instead of saying the length, so if you click on variables here and click make a variable, we'll call it length. And now you'll get these new blocks. So I'll say, well, I don't want to move 4 spaces, I want to move length spaces. But the program doesn't know what length means yet, so we've got to declare some value. So at the beginning up here, I'm going to declare a length of 4. So pull out that set, and then you'll have to pull that arrow down to length and start at 4. So notice if I ran this, it would actually do the exact same thing as our other code did. I took the wait block out so it does it a little faster. If I hit the space bar, it all clears off. And now here comes the fun part. Like if we're like, oh, we want to make not just that outer square, but smaller inner squares over and over and over. So what we can do is actually change that length by a small amount. So let's say we change it by negative 0.2. If you change it by negative 0.2, now it's at 3.8, and you could make a new square. So that would require us to either duplicate this code again or just loop it back through. So I'm going to disassemble that and go in the control menu, pull out a repeat, and let's just package that in there and say, okay, let's just repeat that 10 times and see what happens. So now, again, this is going to make the square. It's going to change the side length of the square by negative 0.2, so it'd be 3.8, and it's going to loop it back through, and it's going to do that 10 times. Oh, interesting. And if we zoom in there, we still got some left. Now, if you think about what is the length at right now, if we've done 10.2s, that's a total of 2. So we went from 4 down to 2. So we actually would want to do this 20 times to bring it all the way to 0 instead of 10 times. So I'll hit the space bar to reset it, run it, and there we have a base. Now this is not the only way to make a base, but it is one way to fill it in, and it's fun for kids to think about that pattern recognition. So then if we wanted to build the walls up, so now let's say we're going to make it hollow and we're going to build the walls up around. One way to think about that is if you go to the motion menu and click change absolute. Instead of the absolute Y, I'm going to click, or X, I'm going to click the absolute Z. So I'm going to reset, I'm going to zoom in on my beetle, and if I click just that block, notice how it bumps him up, pumps him up. If I hit the space, resets him back down. All right, so this is how you change the absolute Z, a direction up, and then once you do that, you just want to build the outer square that you started with. But remember, we've dwindled our length all the way down to 0, so we actually have to reset that length back to 4, because we went from 4 and kept taking off 0.2 from it over and over. Then we're going to bump it up, and then we're going to make our square again. So one thing you can do, let me just pull this out of here, and I can, oops, somehow that got goofed up, sorry about that. I can actually just right click on this and click duplicate. And what that means is I now have the code here for a square, right? So this does the square, and I've done that by right clicking and selecting duplicate. Now I've got to put this stuff back in this original loop. Sorry if that goofed you up. If you've never linked before, it might take you a second to clean that up. But let's take a look at what that does then. So if I zoom back out, run this code, bumped up one full spot and made a new square, right? That's what we wanted it to do. Looks like that puts a pretty big gap in there, so I'm not going to bump up by a full 0.1. I'm going to change it to something smaller, like let's say 0.2, so then it will be a little cleaner. And then what I really want to do is loop that through to keep building squares up. So a lot of looping in this particular lesson. It's really good for kids to think about. So we're going to repeat that. Let's just say we're going to repeat that 10 times. So I want to keep changing the absolute Z. I really don't want to keep resetting the length to 4, right? I don't really need to do that. I can just reset it once and then it's back where it was. And this is just going to repeat that code that was bumping up and making a square, bumping up, making a square over and over. So reset. Cool. And then so like this is just bumping up, making squares. Maybe I don't think that's tall enough, so I got to do it more times. I'll do it 20 times and run that. And you can play around with different values and different things, but essentially that's going to build the wall up. Now, what's interesting is that we already have the code for the base, right? If you think about it, this chunk up here made the base. So I'm going to show you a little more of an advanced skill here, and it's called a function. They call it myblocks, but in algebra, when you've done all those functions, we could just call this base. And hit enter, and it's going to say, well, what's the code that goes along with the base? So in Beetle blocks, you actually have to drag the code. This is the stuff that made the base, drop it in there, and it will remove it from the picture out here. A little different than Scratch if you've used Scratch before, but now this function right here makes a base. So let's say we just ran that right there. So I'll do spacebar, and I'll just run that. Notice how that one single function block is making the base. Well, why is that valuable? Because to close off the top, all you have to do is make the base again. So I'm going to reset. And hopefully now you see the value of the function within this particular program, right? The function allowed you to not have to repeat all that code, but easily call it back up and duplicate a bunch of code that was previously written. So this was the lesson I wanted to deliver just to get you started. If you have a 3D printer and wanted to 3D print it, you go to this file button and click this as download 3D model as, and you can click STL right here and you'll have a file to 3D print. So thank you guys for watching and good luck.